This video is all about the laws of logarithms. So the learning objective is I will learn the laws of logarithms so that I can simplify log expressions and also solve equations involving logs. So write that down, please. Pause the video so you've got time to do that, and then we'll get started. So there are 3 logarithm laws that you need to learn. You need to learn these off by heart, but they're quite simple. The first is the multiplication law. This law is that the log with base a of x plus log with the same base of y is equal to the log with base a of x multiplied by y. The second law is the division law. It's very similar. It is that the log of x with base a plus the, not plus, that's the same law, minus the log of y with base a, what a nightmare, equals the log, still with base a, of x over y. You can put that in brackets, just like you can put this in brackets if it's clearer for you. The final law is the power law. This is the log of, with base a, of x to the power of k is simply equal to k of the log with base a of x. In other words, if there's a power, you can bring it round to the front and multiply the whole log by it. So these are the 3 laws of logarithms that you need to remember. You definitely need to write these down. So if you haven't already done that, pause the video so that you've got time to do it. And we're also going to look at a couple of special cases when you've done that. So those are the laws. These are the special cases. So the first special case we're going to look at is the log with base a of 1 over x. Using one of the 3 laws, I want you to simplify that logarithm. So pause the video, give yourself time to think about it, and press play when you're ready to see how I do it. You might have gone for division law for this, because obviously it looks quite similar to the division law, but it's not actually going to be very helpful in terms of simplifying it, because if you use the division law for this logarithm, you're going to end up with 2 different logs, which is actually not very helpful, because usually we want to go from more than 1 log to just 1 log, because then it's easier to deal with, because it's simplifying. So we're actually going to use the power law. 1 over x is the same as x to the negative 1. And so therefore, that is the same as negative 1 or negative log with base a of x. So all I've done there is I've brought the power down to the front. So that's the first special case. Make sure you've written that down. Second special case, and you could have figured this out after our last video actually, is the log of a with base a. In other words, a to the power of what makes a? Obviously, it's just 1. So whenever you see something like this, you can simplify it to 1. And finally, log with base a of 1 is equal to, what do you think that's going to be? A to the power of what makes 1? Well, 0, because anything to the power of 0 makes 1. So whenever you see this, you can say that it is equal to 0. And that will help to simplify. So make sure you've written down these laws and the special cases, because today's video And also the next couple of videos are going to be using all of these. So pause the video so you've got time to do that, and then press play when you're ready to do some examples. So example 10 says write as a single logarithm. Now remember, these log laws only work if the bases are the same, but you can see in all of these that the bases are the same. So pause the video and have a go at applying the log laws to these questions. Press play when you're ready for me to go through them. Okay, so question A. We can see that the bases are the same and the logs are being added. So we are going to use the multiplication law. So those two combined are the same as 6 times 7, which is equal to log base 3 of 42. Don't need to write the brackets, but you can do if you want. So obviously, if you got that right, give it a tick. For B, again, the bases are the same, but this time we're subtracting. So that simplifies to log with base 2 of 15 over 3. It's always the first divided by the second, which is the same as log with base 2 of 5. C, this time we're going to combine two different logs. Now, first of all, I can see that both this one and this one have got coefficient. So I'm going to use the power law. So the first log is going to change to log of base 5, 3 squared, plus log base 5, 2 cubed, which is obviously the same as log base 5 of 9, plus log base 5 of 8. And now I'm going to use the multiplication law because the bases are the same and we're adding. So that simplifies to log of base 5, 9 times 8, which is log of 72 base 5. Technically, by the way, you're supposed to say log of 72 base 5, but sometimes it's easier just to say the base first because that way it's clear thinking. That's the answer. D, finally. Again, we can see the bases are the same, 10 and 10. So because this is a subtract, we're probably going to be using the division law. But first of all, I can see this second log here can be cleaned up a little bit. So I'm going to write it out, just the question out here, so it's easier to follow my working. So the first thing I'm going to do is use the power law. I can see this coefficient here. So this is log of base 10 of 3 minus log base 10 of a half to the power of 4. So I'm just going to simplify the second log. A half to the power of 4 is 1 over 16. And so now, because the bases are the same, it's 3 over 1/16, which is equal to 3 times 16, which is just 48. So you can see with all of these, we've started off with more than one logarithm in the expression. There were actually two in all of them. But for each of them, we've managed to get it down to just one. Now, just like with trigonometric identities and equations involving trigonometric functions, for example, sin, cos, and tan, you always want to try and use the identities to make them so they were just one function. Because if you didn't have just one function, it's very hard to solve the equation, and normally it's impossible. So we can simplify logarithms like this so that we just have one logarithm, and from there, it's much easier to solve if it's an equation. Obviously, for all of these, they're very easy to calculate with a calculator. You just write them in like we practiced yesterday. So pause the video and make any notes that you need to, and then we'll move on to the next example. So this is kind of just the opposite way around to what we were doing then. You need to write in terms of log x, log base a of x, log base a of y, and log base a of z, each of these logs. So pause the video and have a go at doing that, and when you're ready, press play to see how I do it. Okay, so for a, we're going to be using the multiplication law, but like the opposite way round. So it's log of base a for all of them, and because they were being times together here, now we're adding them when we separate them out. But because it's asking in this form, I can't have powers around the x, y, and z. I need to move the power down using the power law. So this squared and this cubed, I need to write nicely as 2 log base a of x plus log base a of y plus 3 log base a of z. And that's the answer to part A. Part B, I'm going to write log base a x over y cubed. Now, as you can see, the first thing we're going to deal with is the division law, but then ultimately we're going to have to deal with this power at some point. So let's simplify this first using division law. So log base a of x minus log base a of y cubed, and then I'm going to bring the power down using the power law. And that's my answer there. Part C, I'll write it all out nicely first. So the first thing I'm going to do is I'm going to use the division law to separate the x root y from the z. So it's a minus log base a z. And then I'm going to split up the x root y so that I've got it in the form that the question is asking me for, which is separating out the log, the log x, log y, and log z. So I'm going to change this to log base a of x plus log base a of root y. And obviously I've still got the log base a of z there. But log base a of root y is not the same as what the question is asking me for. So I need to rewrite this root as a power and then use the power law. So you can see there I've brought this power down to the front. So that's quite a nice question, part C. It's combining all three of the laws that we looked at the beginning of the video. For part D, I'll just do it over here. First thing I'm going to do is I'm going to separate out using the division law. The next thing I'm going to do is, you can see I've got this power here, so I'm going to bring it to the front using the power law. And you'll have probably already noticed this, but log of base a of a, this thing, that simplifies to 1, because a to the power of 1 makes a. So I'm going to rewrite that as minus 4 times 1, which is obviously just minus 4. Now, over time, you'll get to a stage where you see all of this, and you just immediately are able to simplify it to 4, because you can see how it all falls out. So I don't mind if that's something that you start to do during your practice today. In fact, I encourage it. Obviously, if you go wrong, then take a step back and look at the working and make sure you're showing your working really clearly. Next example. So we're now going to start to use the log laws to solve equations. Now, as I said, in this question here, solve the equation where we've got two logs equal to something. Logs are functions. So just like if we had sine of something plus cos of something, we need to get them both so that they were the same function, just one sine function or one cos function or one tan function even. We have to do the same thing with these. We have to combine the two logs to make them into one log. So I want you to pause the video and have a go at doing this yourself before I go through it. Press play when you're ready for me to start. So I can see this straight away. There's a plus and they have the same base. And if they have the same base and there's a plus, I know I can use the multiplication law. But before I use the multiplication law, I've also noticed this one's got a coefficient of 2. So I need to move that coefficient round using the power law. So log of 4 with base 10 plus log of x with base 10 but x squared equals 2. Now I'm going to use the multiplication law. So log of base 10, and then I'm doing 4 times x squared, which is just 4x squared, equal to 2. Now at this stage, we're going to use sort of kind of our common sense about what we know about logarithms to solve this problem. Rewriting a logarithm as a power, we know the base is 10, the power is 2, and it equals this. Ten to the power of 2 equals 4x squared. And from here, it should be fairly easy to solve. It's just 100 equal to 4x squared, divide both sides by 4, and then square root. However, you'll notice my answer is only a positive 5. It's not plus or minus 5. Can you think why? Pause the video if you're not clear, if you haven't realized yet why. And I'll give you a hint. You need to look at the original question. So if we take the original question's logarithm, if we look at this part, it's saying 10 to the power of something equals x. Obviously, we don't know what that something is, but it doesn't matter what this is. It doesn't matter if it's negative or positive. 10 to the power of anything will always be greater than 0. Because 10 to the power of negative 1 is 1 over 10, positive 1 over 10. 10 to the power of negative 3 is positive 1 over 1,000. 10 to the power of 20 is obviously some really big number. So it doesn't matter what the power is, always is going to be greater than 0. So therefore x is always going to be greater than 0. So therefore when we go back to the square rooting over here, it's going to be positive 5 only, not negative 5. So make any notes that you need to. If you need to rewatch that bit to get your head around it, then obviously do that. And then we'll do one more example. So example 13 says solve the equation, and it gives you the equation involving two different logs. Pause the video and have a go at solving this. Alright, so I can see they've got the same base and we're subtracting, which means I'm going to be using the division law. It's always the first thing divided by the second thing. And so again, we're going to kind of use our common sense in terms of what we know about logarithms to solve this. I'm going to set it out as a power. What it means is 3 to the power of 2 equals this. So obviously that's 9 equal to x plus 11 over x minus 5. Multiply both sides by x minus 5. and then solve the equation in the usual way. And so you can see x equals 7. You could check that obviously by substituting it back in. So if you typed into your calculator log of base 3 of 7 plus 11, in other words 18, minus log of base 3 of 7 minus 5, which is obviously 2, then the answer should be 2. So it's, as always, you can check by substitution. So that's the end of this video. You're going to get on with exercise 14E now. Good luck, and obviously if you need to rewatch any part of this, then please do.